Hello everyone, welcome to the channel. Continuing with the questions of Gujcet 2019 paper. Let's go to the first one. The question here is rate of change of area of rhombus with respect to its side. So rate of change, so we will take dA. With respect to side, we will take dx is equal to x. Side we have taken x. Okay, so what is the area of the rhombus? D by dx of area of rhombus is side square into the angle made between the two sides. Differentiate with respect to x. So x gets cancelled and sine theta is half, which is a value in the first and second quadrant. So theta becomes either pi by 6 or pi minus pi by 6, and that is pi by 6 and 5 pi by 6. Option C it is. So here we have an integration question, and this is composite part. So we will take it as t. And because it is function raised to function, let's apply log on both the side. Differentiate both sides using uv dash. So x derivative of log ex into ax derivative and then derivative of x log t derivative. Okay, simplify this, bring t on the left side and log ex will write as log e plus log x because we don't find any e term in here. T is ex raised to x and log e is 1, so it is going to become 2 plus log x. So we observe the whole thing here is going to become dt, integration dt, which is t, and the value of t is e raised to ex raised to x. A option. Let's go to the next question now. So here we have sin x upon sin x minus alpha. So we will write numerator term as sin x minus alpha plus alpha, so that this can be taken as a and this as b, applying formula sin a plus b. After applying the formula, you get this, and now separate the terms. It becomes cos alpha because sin x minus alpha and this will get cancelled in first term. Second term will become cot x minus alpha into sin alpha. Remember, the variable is x, so alpha is constant. Cos alpha integration dx plus sin alpha integration cot x minus alpha dx. Integration of dx is x, integration of cot is log modulus sin x minus. Now compare with the coefficients here. So we find that p is cos alpha and q is minus sin alpha. So if we multiply and divide by 2, it becomes sin 2 alpha, that is minus half sin 2 alpha. This is so easy question. Let's put root x as t. So x becomes t square, differentiating on both sides. And let's put this value in the integral. Root x is t, dx is 2t dt. So this is a question where we have to integrate by parts, applying integration uv. So here our u is t and v is e raised to t. So according to integration by parts, we have So now we will take e raised to t common and put the value of t. It is root x. Here it is root x. A question on definite integration, but since that is raised to -1, we'll interchange it. Take the reciprocal. And we observe that if we write in this manner, it is f dash upon f, which formula for this is log modulus fx. So here it is going to become 2 as it is outside and log modulus x square plus 1. Now put in the limits, upper limit and then minus the lower limit, and get your answer. Leave the answer in the comment box. This is a question on definite integration. Value is given, we have to find k. So integrate, simple one. X integration is x square by 2 and 3 is 3x. On putting the upper limit and lower limit, we get so that makes it k square minus 3k plus 2. So that is a quadratic, bringing 12 here and then splitting the middle term. The factors are k minus 5 and k plus 2, and so the value of k is 5 or minus 2. Question with minus a to a, so we have to first check whether it is even or it is odd by putting x as minus x. So let us substitute x as minus x here. Now cos of 2 into 2 minus x, that is cos of minus 2x, is actually cos 2x. And this is 25 raised to minus x. Is not equal to fx, is not equal to minus fx, neither even nor odd. In that case, we apply f of a plus b minus x. And here minus pi by 2 plus pi by 2 is going to be 0, 0 minus x. So minus x. So in fact, when we apply a plus b minus x, here the function is going to become f of minus x. Let us put it down from here. Now let's add this I plus I. So I have taken cos square 2x common and put the rest of the term. Now we'll write 25 raised to minus x as 1 upon 25 raised to x. After putting 25 raised to minus x as 1 upon 25 raised to x and taking LCM, we have this. Now add both of this term. It will get cancelled because denominator is same. It's going to become 1 plus 25 raised to x upon 1 plus 25 raised to x. And we are left with cos square 2x. Even function, 2 times 0 to pi by 2. And cos square is to be integrated by taking 1 plus cos 4x dx, because we have used the formula 2 cos square theta is 1 plus cos 2 theta. Now integrate and put the limits. Integration of sine cos 4x is sine 4x by 4. First we put upper limit pi by 2. 4 into pi by 2 is 2 pi, sine 2 pi is 0. And on putting the lower limit, it is 0 only. So answer is pi by 2. C option over here. Application of integration question. Curve y is equal to sin x bounded from 0 to pi. So let's take 0 to pi y dx. So in here, because this is a function of the type 2a minus x is equal to fx for 0 to 2a, it will become 2 times 0 to a fx dx. So that becomes 2 times 0 to pi by 2 sine 2x dx. Now we integrate sine 2x, which is cos 2x, of course, minus upon 2. Put the limits. Cos 2 into pi by 2 minus cos 0. Cos pi minus 1 minus 1, and that is 2. So the area of the curve is 2, and the shortcut method for doing this is as many quadrants covered. Here we covered 2 quadrants, so the answer will be 2. Area bounded by ellipse. So first let's convert the ellipse to the standard form. This becomes upon half, and this becomes upon 1/3. For finding the area is pi AB. So our A is 1 by root 2 and B is 1 by root 3, because these values are A square and B square. So the answer is pi upon root 6. Question is integrating factor of the differential equation. Now in Gujcet papers, one question of integrating factor is mostly asked, and one more question which is common is binary operation question, finding the inverse of the element, which I have taken up in the previous video, so you can have a look at that. Now going to this one, integrating factor. First let us convert this to the standard form, dividing the whole equation with 1 plus x. So our p of x is minus x upon 1 plus x. So the integrating factor is e raised to integration px dx. So we need to integrate this. First of all, we'll put the minus outside, and we'll add 1 and subtract 1, so that it becomes like the denominator. In integration, whenever the degree is same, we try to adjust the numerator. So this is what we have. Integration of 1 is x, and 1 upon 1 plus x is log modulus 1 plus x. So this becomes e raised to minus x plus, and then we can separate this term. It is e raised to minus x into e raised to log 1 plus x. E log being inverse functions will get nullified, and we have e raised to minus x into 1 plus x. Okay, that's well, that is option C for us. We are looking for the order of the differential equation whose general solution is this. So we know that to find the differential equation, we have to differentiate as many constants in the equation, that many times. But over here, this is actually one constant only, so we will call it k. Also, e raised to x plus a6 can be written as e raised to x into e raised to a6, which again is one single constant. Say m. So in fact, in this solution, general solution, we have 1, 2 and 3 constants. So the order of the differential equation will be 3. The question is if vector x is a vector in the direction of this with magnitude 6. So let us find vector x, which is 6 into a cap, for we have said this is vector a. So 6 vector a upon its magnitude. That becomes 6, 2 minus 2, 1 upon magnitude is root of 4 plus 4 plus 1, that is 3. Simplify. Okay, same way find vector y, which is a vector in the direction of this vector, say b, with magnitude root 3. So y is root 3 b cap. Vector upon its magnitude, 1 square plus 1 square plus minus 1 square, root 3, cancel. Now find x plus 2y and hence its magnitude, then its magnitude. So it's simply going to add this is, sorry, not 5. So we are simply going to add this. 2 into y is 2, 2 minus 2, which becomes 6 minus 2 and 0. So the magnitude of this is root of 6 square plus minus 2 square. Root 36 plus 4, root 40. 42 root 10. The main part in here is this thing. If you get this right, the rest is easy. Here we have, if magnitude of x equal to that of y equal to that of x plus y is 1, then we have to find this magnitude. So first we will start with magnitude x plus y square. As such, we should be doing magnitude x plus y dot x plus y, but for MCQ we can write it directly as like a plus b whole square formula. But don't write ab, write x dot y. Magnitude x is 1, this is 1, 1. So let's take 2x dot y on the left side. Simplify, value is 1. So going to this one, because we know that this value will have the middle term as minus 2x dot y. So I have taken like that. You can simply find 2x dot y also. Then you would get minus 1. Applying the formula like a minus b whole square. But remember, don't write ab, write x dot y. This is 1, this is 1. And minus of 2x dot y is also 1. Value is 3 for square. So the value for magnitude x minus y is root 3. So we have completed all the questions related to the syllabus of this year, that is 2020. And this was a paper of Gujcet 2019. So tomorrow I will be uploading the questions of 2018. Most probably I'll try to complete half the paper. So keep watching the videos, subscribe the channel, hit the bell icon, like the video. Also do share it. Thank you.